This is agenda outline. The key topics will cover in this presentation, providing an overview of infrastructure as code, Terraform workflow, best practices, and key considerations. What is infrastructure as code? You heard about actually IaC. Uh, IaC allows us to automate infrastructure provisioning and management, reducing manual effort and increase consistency. This approach is essential for modern cloud environment. Automation and consistency, scalability, version control, and faster deployments are the key benefits of this IaC. Why use IaC? Uh, by treating infrastructure as code, teams can collaborate more effectively and track changes in version control and ensure security and compliance. It allows for rapid recovery in case of failures. Introduction to Terraform. Actually, what is Terraform? Terraform is a widely used tool for IaC that allows to infrastructure to be provisioned and managed across multiple cloud providers using a simple and powerful language. Terraform is an open source IaC tool which created by HashiCorp, and it's used declarative configuration language, which is HCL. Why Terraform? Terraform is open source tool developed by HashiCorp, and declarative approach. You can specify the desired end state, and it's cloud agnostic. It can works with AWS, Azure, Google Cloud Platform, and many other providers. And it has large ecosystem of providers and modules. It has state management for tracking resources. Other popular IaC tools, AWS CloudFormation, Azure Resource Manager, Google Cloud Deployment Manager, Ansible, Chef and Puppet, Plumi. These are the other IaC tools. Actually, these are native AWS CloudFormation is native AWS services for managing AWS resources. And Azure Resource Manager is used for native Azure services, Azure Service Manager, Azure services for managing Azure resources. And Google have Google Cloud Services as Google Cloud Deployment Manager. These are actually native popular IaC tools. Why Terraform stands out? Actually, let's compare Terraform with other IaC tools in terms of provider ecosystem and state management. First, Terraform supports over 100 providers and 1,000 plus resource types, making it highly managing infrastructure across multiple cloud platforms and third-party services as well. In construct, other tools are often limited to single cloud provider or have fewer integration, reducing their flexibility in multiple cloud environment. And next, state management. Terraform provides sophisticated state management tracking, ensuring infrastructure changes are applied predictable and safely. And other, when compared to the other tool, often lack of comprehensive state management or required additional solution to track infrastructure states. Next, language and usability. Terraform has HCL is purpose built for infrastructure description and cloud formation, and Azure Resource Manager has JSON and YAML, can be verbose and harder to work with cloud formation and ARM. And Lumi programming languages offer flexibility but may introduce complexity. And Terraform is a single tool language for all providers. So it's multiple cloud supports, and native tools has required learning different tools for each cloud, and configuration tool of often required additional setup for cloud provisioning. And Terraform has large community and documentation and modules extensive, and others has a smaller community and fragmented across platform. As you can see, this is Terraform workflow. Terraform file has extension is .tf file, and it has we need to initialize download providers and plugins firstly. So we use Terraform init and set up backend for state storage. We have a state file, so we need to keep those files in storage. After we can execute the, we run the plan, Terraform plan. Then we can preview the changes before applying and show what will be created, modified, or destroyed resources. And applying, that is use Terraform apply. When we run the Terraform apply, execute the plan changes. Then after the update the state file as well. And finally, if we don't need this created resource, we can destroy the resource as well. We use Terraform destroy. Those are the key commands in Terraform. This is the basic Terraform initial example. This start in Terraform block. It has required providers, Azure AD and Azure CF, and required version. Required version is Terraform version. And inside this provider, Azure ARM is Azure Resource Manager. It's actually, its provider allows to Terraform to manage Azure infrastructure resources. And second one is Azure AD. Azure AD is, this provider is used to manage Azure resources like users, groups, and applications. And this Azure CF is a cloud adaptation framework. This provider helps to standardize Azure resources naming conventions following Microsoft cloud adaptation frameworks. And finally, this is the Terraform required version. It's necessary. Terraform state management is Terraform maintains the state file that record current states of infrastructure. This enables tracking for changes and prevent unintended modifications. This state file can store in, when we use Azure, we can use Azure blob storage. AWS, you can use S3. Likewise, we can store the state file. Terraform modules. Terraform modules is reusable Terraform configuration. It's helped to break infrastructure into reusable component, making it easier to manage and scale complex setup. Why use modules when it comes to this simplify the management of complex infrastructure and code reusability and improve the maintainability other usage of modules. Best practices for Terraform. Following best practices helps ensure Terraform configuration remaining manageable, secure, and scalable. Using version control and remote state storage improve the collaborations. Challenges and consideration. Actually, Terraform is powerful, but there are few challenges such as manage state file and secret and securely. And it's also important to monitor for configuration drift. And it has a learning curve for HCL. There is small learning curve. Yeah. Conclusion is IaC and Terraform make infrastructure deployment easier and more efficient. Yeah. Okay. I'll show quick demo. This is the main.tf. TF is .tf is extension for Terraform file. I'll describe this code actually. Before this initialization part, I'll show how to install this Terraform. We have a HashiCorp developer documentation. So we can download this Terraform, Linux, Mac OS, Windows. Yeah, after the installation, we need to set up environment variables as well. So okay, I'll move to the code. Yeah. This is the this block describe actually Terraform configuration. There's required providers. I use this. I'm trying to deploy container app to our Azure environment. I'm trying to demo this one. So initially, we have a we need to these providers: Azure ARM, Azure Resource Manager versions, and we need to Azure AD. This actually we use just like library, and after that Azure CF, Cloud Adaptation Framework, and required version. These are the providers. Initialize the backend versions and dependencies. Then it create like these sections, and Azure ARM, Azure Resource Manager has subscription and tenant ID. Those are the for the demo. I hard coded this Azure subscription and tenant ID. And initially, I'm trying to create a resource group. So I named it RG Digital400, and location East US. And when we create container app, we need to container app environment. So unless we can't create container app, so after creating resource group, it's necessary to create container app environment. So in here we can refer this location and resource group in here, and I'm hard code this name for container app environment. And second, then we can use this creating a container resource. As I told earlier, it's when we deploy container, we need to resource group and container environment. We use this when we creating container, we use container environment ID. Yeah. Okay. I'm trying to create this in Digital400 environment. So there are 3 resource group. Sorry. As I mentioned in presentation, after we initialize our libraries, we need to run Terraform plan. Yeah. Actually, it's compared to our Azure environment and our code using this state file. So in here, there is no container environment called test app environment. So there is no container called test container. So these are in plus mark. You can see this added this container in app environment and container app. And this is resource group. There's no resource group called RG slash Digital400. So if we before we apply this Terraform plan, we need to check this plan carefully. We need to preview these changes. Actually, it shows what will be created, modified, or destroyed. So we need to carefully look at this plan, and after finish, we can apply. Do you want to perform this task? Yes. Firstly, started to Azure Resource Group creating. Then after complete, started to app environment creating. While creating, you can see here this resource group. Inside this resource group, there is no resource. Yeah. This is test app environment. Take few time. After it complete, start Azure container creation. Yeah. Apply complete. 3 resources added and no change. 0 destroyed. Here 3 resources were created. Resource group, container app environment, and container app. Yeah, we can see refresh. Yeah, test container. And also we can destroy this as well. we can use destroy Terraform destroy keyword to for destroy this resource as well. Yeah. Thank you for your attention attending this